Welcome to yet another class of Dr. B, your science teacher online. Today, you and I are going to be discussing something also very important, and that is properties of radiation. Properties of radiation. Don't forget that in this class, you owe me a duty to share this class. Share this class to your friends, to your colleagues, share this class to your well wishers, and let them know that all they need to do is to subscribe. Subscription is free as far as this very site is concerned. It's Dr. B Science Classes. Dr. B Science Classes. So they subscribe so they can have these videos come up whenever they are produced. Okay, and now they can also leave comments. Okay, even if there are questions, we're going to attend to them. They can also share this class and leave likes. Even in Facebook, we have Dr. B Science Classes on Facebook. All they need to do is to click on follow, and every time these videos are out, they will get to have them. They can like and also share and leave comments, even if there are questions. Thank you very much. Now, this is properties of radiation. We are not going to just first talk about the properties of radiation. Let us throw a little light on what radiations are all about. Radiations are quite very dangerous, but they are in one way or the other helpful, especially in the medical field. So radiations are used somehow even in the treatment of a higher degree of cancer. Now, radiations are also used in treatment of tumors, especially radiations from radium. Okay, now I want us to know that radiations, the term radiation started coming up when people talk about radioactivity. Okay, radioactivity is that particular part of chemistry that you see us talking about radiation. So um, um, you have radioactivities where you talk about radioactive particles out of radioactive materials or elements. Now, this began with people known as Maria Curie and Pierre Curie. Maria Curie was the wife of Pierre Curie. Maria Curie was a chemist and the husband was a physicist. Now, both of them were scientists, and they were the ones who began talking about radioactivity when they found out that there were some elements that have some radioactive tendency. That is to say, they could give out radiations at the end of the day. It was in that process that Maria Curie, as she is called, was able to understand that those materials, one of them was actually uranium. Now, uranium is a radioactive material and is highly radioactive, so it can give out radiations at the end of the day. She was also able, with her husband, to be able to detect another radioactive material called thorium. So, uranium and thorium were two basic and very first radioactive materials discovered by Maria Curie and Pierre Curie a long time ago, around the 18th century. Now, these two worked hard to understand what radioactive materials were, and how radiations were possible in this regard. Now, both of them suffered radiation problems because they didn't understand that those materials that they were working with were capable of giving off radiations that are quite dangerous, and they had serious anemic problem that came as a result of prolonged exposure to these radiations that later killed them in 1934. Now, these two persons were the very first people that brought about the issue, the item, which is radioactivity. Now, the understanding of actually what radiations are were brought about by Henry Becquerel. Henry Becquerel was the man who, after the death of Maria Curie and Pierre Curie, now was able to talk about radiations. And this he did very simply when he tried to pass uranium, as a matter of fact, uranium through photographic films or plates or papers. Now, when he passed uranium elements as a phase, uranium powder, through photographic films and plates, Becquerel understood that after some time, when exposed especially to light, they were going to blacken that particular film. And from there, though he was thinking that it was more of fluorescence because that was the chemistry that Becquerel was really interested in, but later on understood that it was not about fluorescence, but that it was an emission of radiation that comes from the uranium material that blackened the photographic film. And that is why to test for radiation, you use a photographic film or plate. Now, that was one way that it was possible for Henry Becquerel to understood that radiations were actually being given up from radioactive material as discovered by Maria Curie and Pierre Curie. And after that, he tried also to use the thorium and also tried to use radium and polonium that were actually radioactive material discovered by Maria Curie and by Pierre Curie. Now, his action gave light to the world of physics and chemistry, understanding the dangers of radiations that come from radioactive material, though himself as Henry Becquerel also suffered radiative problems because of his constant carrying of radium material in his pocket in the course of his research, and he suffered the consequences of carrying radioactive material like radium alongside with him. Now, this is more I can tell you about the history of radioactivity as it is being written. Now, it is from the work of Henry Becquerel that we understood that radiations are actually given up through photographic film exposure to uranium, that we now talk about the properties of radiation. Now, it is good for us to know that when radiations were studied using photographic film, it was understood that there are three types of radiative materials that can be given up in every radioactive element. And one of them is the alpha radiations, and the second one is the beta radiations, and the third one is the gamma radiations. So we have three basic radiative materials, radioactive materials rather, that can be given up in the course of emissions from radioactive elements. And I said one of them is the alpha ray, or you can call them alpha particles, and then we have the beta ray or the beta particles, and we have the gamma ray or the gamma particles. These are three basic particles you can find as radioactive materials that can actually be emitted in the course of radiations. Okay, all of them tend to be quite dangerous. It depends on which one falls on you and at what time. Now, it is important for us to know that the alpha particles and beta particles are known seriously to have quite a very low penetrating power compared to the gamma radiations. Now, it was understood that the alpha and beta particles were capable of being transmitted through air. Now, because they were being transmitted through air, they were further studied in terms of their properties to understand how far their transmissions will go. Now, that was where it was understood that alpha particles were actually ions, unlike the beta particles that are known to be electrons. Okay, so one of the basic property of these radiations, especially for these three, is that alpha particles are ions, especially helium ions. And that is why you're having the helium ion written here, defining an alpha particle, going with +2 charge. Now, both of them are charged particles. Alpha particles and beta particles, or radiations, are charged radiations. Now, they are charged radiations. The reason they can be bent. Now, when you decide to allow these radiations to pass through electromagnetic field, or to pass through an electric field, there is a tendency that both radiations will bend, especially alpha particles and beta particles will show a bend, which means that these particles are charged particles. Now, but the beta particle will bend more easily in the presence of these very electromagnetic waves or electrical waves, they could bend more easily. The most reason they are actually electrons and not mere ions like the alpha particles. But generally, we should know that alpha and beta particles bend in the presence of electromagnetic waves or even electrical waves. But one of them is the alpha, which is a beta particle, bend more easily compared to the alpha particles. Now, the gamma radiations do not have charge. They have a neutral charge, and that is why you see we have 0. But it's important for you to know that looking at another property, gamma radiation show more or show a higher penetrating power than the beta and the alpha radiations. Both radiations show penetrating power. Okay, but the gamma radiations show a higher penetrating power compared to the alpha and beta radiations. The alpha radiations show a lower penetrating power compared to beta and the gamma radiations. Now, these beta radiations show a higher penetrating power compared to the alpha particles or alpha radiations. Now, that is still the third you should know is in terms of their frequency. Now, the alpha particles that are known to be actually helium ions that show lower penetrating power have a higher frequency. Now, if you look at the gamma radiations, they have the lowest frequency, even though they have the highest penetrating power. Now, if you take a look at the diagram we have on board here, you will notice that the alpha particles are easily stopped by a thin paper or a thin aluminum sheet. That shows you that alpha particles and beta particles can actually be transmitted through air. But even as they are transmitted through air, the alpha particles cannot go too far. They can be stopped by just an ordinary pieces of paper. Okay, now the beta particles can actually be transmitted also through air, but can penetrate a thin aluminum film or paper, but can only be stopped by a block of millimeters of aluminum sheet. Now we have to know that about 2 to 3 centimeters of thickness of a paper or thin aluminum can stop alpha particles, showing how short their wavelength is. Now, but if you use the alpha, the beta particle, they can penetrate 2 to 3 centimeters of thickness of a paper or thin aluminum sheet. They can be stopped by several millimeters of aluminum sheet or block. You can see that the beta particles have a higher penetrating power, but have a medium they have a higher penetrating power rather other than alpha particles, but they have a medium frequency compared to alpha particles. Alpha particles have the highest frequency. Now, but if you look at the gamma radiations are able to penetrate 2 to 3 millimeters of paper, thickness of paper. They can penetrate a small block of several millimeters of aluminum, but can be stopped by a thick block of lead. You can see this here. So you see that these three radiations possess properties that are very different. Even though all of them are radiation, all of them are actually radiative particles that are obtained from an element. Every radioactive material has the tendency of giving up these three basic radiative particles. But depending on how you want to use them, you now have to choose which you have to use, because none of them have the same penetrating power or even frequency of transmission. So gamma radiations are stronger, and that is why gamma radiations are used mostly in the medical field. In the treatment of tumors in the hospitals, you use radium, and radium is a radioactive material that transmits more of gamma radiations that can penetrate matter. Okay, so you can also talk about higher degrees of cancer that you can treat them where you expose them to radiation. These radiations are exposing them to gamma radiations because of their high penetrating power and low frequency of transmission. So you can see here that there are several properties of radiations, and these properties of radiation depend upon each of the radioactive material that is given up in the course of exposure. So here it's quite clearer, and here we have been able to explain to us what radioactivity is, what radioactive elements are, what radioactive particles are, and the properties of radioactive particles that they are. You read more on this and you're going to see that you enjoy this aspect of chemistry we are bringing to you on board, and that is radioactivity. It's nice having this class with you today. I am sure that you have gained something out of what we have discussed concerning radiations and the properties of radiation, as the case may be. Join us next class and see how wonderful we have good topics to break down for you for your understanding. I remain Dr. B, Science Classes, both on Facebook and on YouTube. Follow me and subscribe, and let us see how far these classes could go. Thank you.